Hello dear students, all of you welcome to Vidyan classes. It is the 8th lecture on function in the chapter relations and functions. Today we will discuss total number of functions, total number of one-one functions, onto functions and bijective functions. Question number 1. Find number of functions from the set A contains AB to B contains XY. Find number of functions from the set A to B. Answer. F1 is a function from A to B. Capital A contains small ab. Capital B contains X and Y. F1 is a function from A to B. The figure shows F2 is a function from A to B. F3 is a function. A it is B, X, Y. A corresponds to X, B corresponds to Y. Is also a function from A to B. F3. F4. A contains small a and B. B contains X, Y. A corresponds to Y, B corresponds to X. F1, F2, F3, F4 satisfies the definitions of functions. So F1, F2, F3 are four functions from A to B. Implies total number of functions from A to B is 4, which is equal to 2 square is equal to B mod to the power A mod. Since A mod is equal to which is equal to B mod, the number of functions from A to B is B mod to the power A mod. Question number 2. Find number of functions from capital A contains small a, b, c to capital B contains x, y. Find number of functions from the set capital A which contains small a, b, c and to capital B which contains x, y. Answer. f1 is a function from A to B. A contains BC, B contains XY, A corresponds to X, B corresponds to X, and C corresponds to X. It satisfies the definition of function. So f1 is a function. f2 is a function from A to B. A corresponds to Y, B corresponds to Y, and C corresponds to Y. It is also a function. F3 is a function from A to B. A corresponds to X, B corresponds to X, and C corresponds to Y. It is also a function. F4, it is A, it is B. A corresponds to Y, B corresponds to Y, and C corresponds to X. Also satisfy the definition of a function. F4, F5. F5, A, B, C. X, Y. B corresponds to Y, C corresponds to Y, and A corresponds to X. Is a function from A to B. F6, A to B. It is A, it is B, it is C, X, Y. B corresponds to X, C corresponds to X, and A corresponds to Y. It also satisfies the definition of function. F7, A, B. A corresponds to X, C corresponds to X, B corresponds to Y. Is also a function from A to B. F8, it is A, it is B. A, B, C, X, Y. A corresponds to Y, C corresponds to Y, B corresponds to X. Is also a function from A to B. So, total number of, in question number 2, in question number 2, in question number 2, total number of functions from A to B is 8, which is equal to 2 to the power 3, which is equal to B mod to the power A mod. Since A mod is equal to 3, B mod is equal to 2. A mod is equal to 3 and B mod is equal to 2. Total number of functions from, in question number 2, total number of functions from A to B is 8, which is equal to the 3, which is same as mod of B to the power mod of A. A mod is equal to 3, B mod is equal to 2. Another example. Question number 3. Find number of functions from the set A contains small a and b to B contains xy. XYZ. A has 2 elements and B has 3 elements. Answer. A, B, C, X, Y. A, B and X, Y, Z. X, Y, Z. A contains 2 elements, B contains 3 elements. F1 is the function from A to B. A corresponds to X, B corresponds to X. F1 is the function from A to B. F2 is a function from A to B. A contains small a b, B contains x, y, z. A corresponds to y, B corresponds to y. Is also a function from A to B. F3 x, y, z. A corresponds to z, B corresponds to z. Is also a function from A to B. F4 F4 it is A, it is B. AB x, y, z. A corresponds to x, B corresponds to y. So F4 is a function from A to B. F5 is A, it is B. A, B, X, Y, Z. A corresponds to Y, B corresponds to X. Also satisfies the definition of a function. F5 is a function from A to B. F6 it is A, it is B. A, B, X, Y, Z. A corresponds to Y, B corresponds to Z. So it satisfies the definition of a function. F7. F7. A correspond to Z and B correspond to Y. Is also a function from A to B. F8. It is A, it is B, X, Y, Z, A, B. A correspond to X, B correspond to Z. Is also a function from A to B. F9. A correspond to Z and B correspond to X. So the total number of functions from A to B, total number of functions from A to B is 9, which is equal to 3 square, which is equal to B mod to the power A mod. Since A mod is equal to 2, B mod is equal to 3. Total number of functions from, in question number 1, number of functions from A to B is B mod to the power A mod. In question number 2, total number of functions from A to B is 8, which is equal to 2 to the power 3, which is same as B mod to the power A mod. In question number 3, total number of functions from A to B is also is 9, which is same as 3 square, which is equal to B mod to the power A mod. From question number 1, question number 2 and question number 3, it is clear that number of functions from A to B is B mod to the power A mod. Very important. A mod is equal to M, B mod is equal to N, implies total number of functions from A to B is equal to is total number of functions from A to B is B mod to the power A mod, which is B mod means N to the power N. It is the general formula to find out the total number of functions from A to B. A mod is equal to M, B mod is equal to N. Total number of functions from A to B is B mod to the power A mod. It is the general formula to find out the total number of functions from A to B. Very important. It is the general formula to find out the total number of functions from A to B. Clear? Clear? Okay. Note down. Note down. Next, note 1 in permutation we have read NPR permutation of n different things taking array time is given by n factorial divided by n minus r factorial, or it is also written as in this symbol n factorial divided by n minus r factorial. If n greater than equal to r, nr belongs to capital N. This expression in 11th class we have read. It is read as permutation of n different things taking r at time, which is given by n factorial divided by n minus r factorial, or in this form n factorial divided by n minus r factorial, where n r belongs to capital N and n greater than equal to 0, and this result is 0 for other cases. In this case, NPR is equal to this. For other cases, its value is 0. Note 2, it is defined by zero factorial is equal to 1. Note 3, for n is equal to r, NPR implies NPN which is equal to n factorial divided by 0 factorial which is equal to n factorial, implies NPN is equal to n factorial, where n is a natural number. For n factorial is equal to n into n minus 1 into n minus 2 dot 3 into 2 into 1. N factor represents the product of first n natural numbers. It is the product of first n natural numbers. Example, 5 factorial is the product of first 5 natural numbers. The product of first 5 natural number is 5 factorial, which is same as 5 into 4 factorial, which is same as 5 into 4. The product of first 3 natural numbers is 3 factorial. 10 factorial this is read as 10 factorial, which is the product of 10 into 9 into 8 into dot 3 into 2 into 1, which is same as 10 into 9 factorial, or 10 into 9 into 8 factorial. Clear? NPR is equal to n factorial divided by n minus r factorial if n greater than equal to r, and 0 for other cases. It is defined by 0 factorial is equal to 1 for n is equal to r. NPR represent NPN which is equal to n factorial divided by 0 factorial is is equal to n factorial. Npn is equal to n factorial. N factorial is defined as the product of first n natural numbers. Clear? Note 1, note 2, the number of injective or 1 functions from A to B is defined by B mod P A mod, where A and B are two finite sets. The number of injective functions or 1 functions from A to B is defined by B mod P M mod, where A and B are two finite sets. Example 1. Find the number of one functions from A to B, where A is the set of AB and B is the set of XY. Answer. Here A mod is equal to 2, B mod is also 2. So, the number of one functions is to P to B mod P A mod, which is equal to 2 factorial, which is equal to 2. 2 into 1, that is equal to 2. The number of 1 functions from A to B is 2. In figure, F1 is a function from A to B. A contains AB, B contains XY. F1 is a function from A to B. F2 is a function from A to B. A contains AB, B contains XY. F2 is a function from A to B. The number F1 and F2 are two 1 functions. F1 and F2 are two 1 functions from A to B. F1 is the collection F1 here. F1 is equal to set of AX order pair and BY order pair. F2 F2 is equal to set of AY order pair and BX order pair. The number of one functions from A to B is 2. F1 and F2 are the one functions. It is the diagrammatic form of a one function. According to the formula, the number of one function is 2p2, which is equal to 2 factorial, which is equal to 2 into 1, that is equal to 2. Clear? Okay. Note down. Next, example 2. Find number of injective or 1 functions from the set A contains a B, to B contains XYZ. Answer: A mod is equal to 2. Number of elements in A is 2. B mod is equal to 3. So, the number of 1 or injective functions from A to B is 3p2. B mod is B mod P A mod, which is equal to 3p2. That is equal to 3 factorial divided by 3 minus 2, that is 1 factorial, which is equal to 3 into 2 into 1 divided by 1 is equal to 6. The number of functions, one functions from A to B is 6. It can be represented in diagram. Diagrammatically, we can represent the number of functions. Number of one functions from A to B is 6. F1 is a function from A to B. A contains a B contains XYZ. Number of one functions. F1 is 1. F2 is a function from A to B. A contains a B contains XYZ. It is also 1. F3, a B, XYZ. Is 1. F4, a B, XYZ. It is also 1. A5, a B, XYZ. It is also 1 1. F6, AB, XYZ. F6 is a function from A to B. It is A to B. It is also A to B. A to B. A to B. So the number of 1 1 functions from A to B is 6. Another example. Find number of 1 1 functions from the set containing ABC to the set B containing XYZ. Here answer A mod is equal to 3. Number of elements in A is 3 and B mod is also 3. Number of 1 1 or injective functions from A to B is B mod, P A mod, which is sum of 3p3, which is equal to 3 factorial, which is equal to 3 into 2 into 1, that is equal to 6. The number of injective functions from A to B is 6. In diagram, F1 is the function from A to B. A contains A, B, C. B contains X, Y, Z. A corresponds to X, B corresponds to Y, and C corresponds to Z. F1 is 1 1. F2 A, B, C. X, Y, Z. A corresponds to Y and B corresponds to X. It is also 1 1 from A to B. F3 A to B, A, B, C, X, Y, Z. B corresponds to Z, C corresponds to Y, A corresponds to X. It is also 1 1. F4 A, B, C, X, Y, Z. A corresponds to Z and C corresponds to X. B corresponds to Y. It is also 1 1. F5 A, B, C, X, Y, Z. from A to B. A correspond to Y, B correspond to, and C correspond to X. It is also 1 1. F6 X, Y, Z. And A correspond to Z. B correspond to X, C correspond to Y, and A correspond to Z. These are the 1 1 functions from A to B. Example 4. Find the number of one functions from A contains, from the set A contains ABC to B contains XY. Answer. Here A mod is equal to 3 and B mod is equal to 2. Number of 1 1 functions from A to B is B mod P A mod, which is equal to 2P3. That means permutation of two different things taking 3 at a time, which is equal to 0. Since A mod greater than B mod. In pair is exist when n greater than equal to r. Here n is equal to 2, r is equal to 3, r is greater than n. Clear? Since 3 greater than 2, the number of arrangement of two different things taking 3 at a time is 0. For example, A contains ABC, B contains XY, AX, it is 1 1, but not a function. It is a relation. 1 1 relation, not a function. Since C does not correspond to any element in B, it is not a function. F2 A correspond to Y and B correspond to this. It is also not a function, but it is a relation. 1 1 relation. F3 ABC XYZ B to C, C to Y. It is 1 1 relation, not function. It is a relation, not a function. F4. F5 is a relation, not a function. One relation. F6 F1, F2, F3, F4, F5 and F6 are one relations, but not function. The number of one functions from A to B is 0. These are the one relations, not functions. The number of functions from A to B is exist if B mod is greater than or equal to A mod. Otherwise, the number of one function is 0. Clear? Okay. Note down. Next. Number of onto function. Number of onto functions. The number of onto functions can be obtained using combination. The number of onto functions that can be defined from the finite set capital A to the number of onto functions that can be defined from the finite set capital A to the finite set capital B is equal to the number of ways of dividing any things into NB groups so that no group is empty. If Na greater than equal to Nb and 0 otherwise. The number of onto functions that can be defined from the finite set capital A to the finite set capital B is equal to the number of ways of dividing n things into nb groups so that no group is empty if n greater than equal to nb and 0 otherwise. n things dividing n things, that means number of elements of A is divided nb groups. The number of onto functions can be obtained dividing the number of elements of capital A into nb groups. If n is greater than equal to nb, no group is empty. The number of onto functions can be obtained dividing n, that means number of elements of capital A, into nb groups so that no group is empty if n number of elements of A is greater than number of elements of B, and the result is 0 for other cases. Otherwise, example, find number of onto functions from the set from the set capital A containing small abc onto the set capital B containing pq. Find number of onto functions from the set capital A which contains small abc and 2 onto capital B containing pq. The statement shows n things, that means number of elements of A is divided into nb groups. nb groups, that means nb sets. Answer: A is the set of ABC and B is the set of PQ, which implies NA, that means modulus of A, that means number of elements of A is 3, and NB is equal to 2. B contains 2 elements and A contains 3 elements. We will divide the elements of A into 2 groups. Na is divided into nb groups. Na is divided into nb groups. Na contains Na is equal to 3, that means A contains 3 elements. Here 3 is divided in 2 groups, that means 2 sets. The first set contains 1 element and the second set contains 2 elements, or the first set contains 2 elements and the second set contains 1 element. A contains 3 elements. So, number of combination or number of groups, so represent the total number of onto functions. So, the number of onto functions is equal to 3 factorial divided by 3 factorial divided by 1 factorial into 2 factorial. 1 factorial into 2 factorial. plus 3 factorial divided by 2 factorial into 1 factorial. 3 factorial, that is equal to 6, 2 factorial is 1, 1 factorial is 1, so the value is 3, it is also 3, which is equal to 6. The number of onto functions from the set A to the set B is 6, according to the definition or statement. The number of onto functions that can be defined from the finite set capital A to the finite set capital B is equal to the number of ways of dividing any things. That means number of elements of A will be divided into NB groups or sets. Set or group or combination. It is the application of a combination. A contains 3 elements. It can be divided in 2 groups. One set contains group or set. One set contains 1 element. Second set contains, first set contains 1 element. Second set contains 2 elements. A contains 3 elements. It can be divided by the first set contains 2 elements and the second set contains 1 element. So the number of combination or group is equal to, in this case, 3 factorial divided by 1 factorial into 2 factorial. In second case, 3 factorial divided by 2 factorial into 1 factorial, which is equal to 6. So the number of onto functions from A to B, from A to B is 6. Diagrammatically, we can show the number of onto functions is 6. In diagram, we can show A contains ABC, B contains PQ, F1 is the first onto function, is a onto function. Since range of F is equal to B, F is onto if range of F is equal to B. Range is the set of PQ. It is the diagrammatic representation of the onto functions. It is also a onto function. Since range of F2 is B. Is a onto function. Range of F3 is set B. F4 it is also a onto function. F6 it is also an onto function. F1, F2, F3, F4, F5, F6 are 6 onto functions. F1, F2, F3, F4, F5 and F6 are the onto functions from A to B. The number of onto functions is 6. These are the diagrammatic representation of the onto function from A to B. Second example. Example 2. Find number of onto functions from set A contains A, B, C, D onto B contains PQ. Here NA answer NA, that means number of elements of A is equal to 4. NB, that means number of elements of B is equal to 2. A contains 4 elements, B contains 2 elements. The number of onto functions from A to B means dividing the elements of A into 2 groups. Represent the number of onto functions. Here A contains 4 elements. We have to divide these 4 elements into 2 groups, which represent the total number of onto functions from A to B. 4 can be divided in 2 groups. The first group or set contains 2 elements and the second contains 2 elements. Or 2 groups. The first contains 2 elements and the second contains 2 elements. The first contains 1 element and the second set contains 3 elements. Or the first contains 3 elements and the second contains 1 element. It is the total number of elements in A which can be divided into 2 groups. Since n of B is equal to 4 is divided in 2 groups. 4 is divided in 2 groups. Either this form or this form or this form. So the total number of onto functions from A to B is equal to 4 factorial divided by 2 factorial into 2 factorial into 2 factorial plus 4 factorial divided by 1 factorial into 3 factorial plus 4 factorial divided by 3 factorial into 1 factorial. 4 factorial means 4 into 3 into 2 into 1, that is equal to 24, divided by 4, which is equal to 6. 24 divided by 3 factorial. 3 factorial means 6. 24 divided by 6, that is equal to 4. it is also 4. That is equal to 14. 14 on two functions can be defined. Total number of onto functions from A to B is 14. Clear? Since A contains 4 elements, B contains 2 elements, these 4 elements can be divided in 2 groups since B contains 2 elements, which gives 14. The total number of onto functions from A to B is 14. Clear? Next example. Example 3. Find the total number of onto functions and the total number of onto functions from A containing ABCD onto B is the set containing PQR. Find the total number of onto functions from the set capital A containing 4 elements onto B is the set containing PQR. Answer: number of elements of A. A contains 4 elements. B, number of elements of B is equal to 3. A contains 4 elements, B contains 3 elements. The total number of onto functions is the same as dividing 4 elements of A into 3 groups, dividing Na into 3 groups. A contains, that means 4 is divided in 3 groups. It is 1, it is 1, it is 2. Total is 4 in 3 groups. The first group contains 1 element, the second group, that means second set, contains 1 element, and the third set contains 2 elements. The first contains 1 element, second contains 2 elements, and the third contains 1 element. Or the first set contains 2 elements, second set contains 1 element, and the third set contains 1 element. So 4 can be divided in 3 groups in this way. Total number of onto functions is equal to 4 factorial divided by 1 factorial into 1 factorial into 2 factorial plus 4 factorial divided by 1 factorial, 2 factorial, 1 factorial plus 4 factorial. It is the application of a combination in 11th class. 4 factorial divided by 2 factorial, 1 factorial, 1 factorial. 24 divided by 2, that is equal to 12. 4 factorial means 24 divided by 2 factorial means 2, 1 factorial is equal to 1, which gives 12 plus 12 is equal to 36. Answer. Total number of onto functions from A to B, therefore total number of onto functions from A to B is 36. Example 4. Find number of onto functions from A contains ABC onto B contains PQRS. Find number of onto functions from A onto B. Answer: NA is equal to 3, NB is equal to 4. 3 cannot be divided in 4 groups, so that no group is empty. A will be divided in 4 groups. It is impossible to divide 3 elements in 4 groups. So the number of onto functions is 0. Total number of onto functions is 0. As NA less than NB. The number of onto functions is possible if NA is greater than NB. Here NA is less than NB. So the total number of onto functions is from A to B. Functions from A to B is 0 as NA is less than NB. Clear? Okay. Note down. Next, number of bijective or 1 1 and onto functions. Bijective means 1 1 and onto. The total number of bijective functions from the finite set A, from the finite set A onto finite set B is defined by NA factorial. The total number of bijective functions from the finite set capital A onto the finite set capital B is defined by NA factorial. NA represents a number of elements of capital A, and is 0 otherwise. Total number of bijective functions from the finite set capital A onto the finite set capital B is defined by n a factorial and 0 otherwise. Example, find the number of, that means total number of, find the number of bijective functions from set A containing ABC onto capital B is the set containing PQR. Number of bijective functions from A onto B is n a factorial. Answer, given A is equal to set of ABC, B is the set containing PQR. Implies number of elements in A is equal to 3, which is same as number of elements in B. According to the definition, so total number of bijective functions from capital A to capital B is 3 factorial. 3 factor means 6. It can be shown in diagram. Diagrammatically, we can show it has 6 bijective functions. A is a set, B is a set, F1 is a function from A to B. A contains small abc, B contains PQR, A corresponds to P, B corresponds to Q, C corresponds to R. F1 is a bijective function since it is 1, 1 and 1, 2. ABC, PQR, F2 is a function from A to B. A corresponds to Q, B corresponds to P, C corresponds to R is a bijective function since it is 1, 1 and 1, 2. F3 is a function from A to B. B corresponds to R, C corresponds to Q, A corresponds to P. Is also a bijective function. F4, it is B, ABC, PQR. A corresponds to R, C corresponds to P, and B corresponds to Q. Is a bijective function. F5, it is B, ABC, PQR, A corresponds to Q, B correspond to R and C correspond to P is also a bijective function. F6 A to B ABC PQR B correspond to P, C correspond to Q, A correspond to R is also a bijective function from A to B. The number of bijective function from A to B is 6. According to the definition or formula, it is 6. By diagram, we can show 6 different bijective functions. Here, F1, F2, F3, F4, F5 and F6 are the bijective functions from A to B. Example 2. Example 2. The number of bijective functions from the set A contains ABC and the set B contains PQ. Answer 0. Since NA not equal to NB. Bijective functions can be obtained when both sets have same number of elements. Clear? A contains 3 elements, B contains, for example, ABC, A contains ABC, PQ. Is not a function since C does not correspond to any element in B. F is not, it is one relation, not a function. F is not a function. Bijective functions or one-to function is possible when both have same number of elements. The number of bijective functions from A to B is 0 since NA not equal to NB. Example 3. The number of bijective functions from A containing AB and B contains. The set B contains PQR. The number of bijective functions from A to B is dash. Answer 0. Since NA not equal to NB. Example 2 and example 3 are same type. Bijective function is possible when both sets have same number of elements. Clear? Okay. Note down. Note down.